So let us go with the last part of today's lecture, and the last part is starts with a homework. The homework is the following. So establish whether the following real sequences are convergent or not. So first is an equal to -1 to the n, the sequence that jumps hysterically from -1 to 1 and backwards. Okay? So second, an is equal to the sine of n pi. Third, an equals the sine of n pi over 2. Okay? Use the definition. Just use the definition. Try to justify every passage of your reasoning, and always be adherent to the definition. Okay? Don't do computations. Here you don't need any computation. So first, heuristically, try to see what happens to these sequences. What is their behavior? Write down A0, A1, A2, and so on and so on. Now, I want to deepen a bit our awareness about the absolute value. So I open here a box. What is the absolute value, which is also called modulus, and that is linked to the intuitive notion of distance. Okay? So this is the definition. Here you have x in R. And so the absolute value of x is x if x is non-negative, and minus x if x is negative. Okay? This is the definition. In particular, I don't like false definitions like it is the number without the sign. The absolute value has a sign. The sign is positive, or at least non-negative. Okay? So in particular, you have that first, the absolute value of x is larger or equal to 0 for every x in R, and the absolute value of x is equal to 0 if and only if. This is a short way of writing if and only if. X is equal to 0. And the interpretation is the distance between x and 0. Okay, this is the interpretation. So, of course, you can also interpret modulus of x as a function. And as a function, it has a graph. And this is the graph. So between these two lines, y equal to x, y equal to minus x. Okay? And so another property is the following. Is that the modulus of x is equal to the modulus of minus x. So you can change the sign inside the modulus without changing anything. Fourth property is that for every x, y in R, the quantity x minus y in absolute value equal to y minus x, again in absolute value, is interpreted as the distance between the points x and y. So, and last thing, is the triangular inequality. The first triangular inequality. That says that the absolute value of the sum of x plus y is less or equal the absolute value of x plus the absolute value of y. So it is not always equal. Okay? Another version of this is the absolute value of x minus y is less or equal the absolute value of x plus the absolute value of y. Okay? It is very easy to say that they are equivalent because indeed you just write down x minus y in absolute value can be written as x plus minus y, everything in absolute value, less or equal absolute value of x plus absolute value of minus y equal to absolute value of x plus absolute value of y. Okay? Of course, the proof is very boring. Let me just give you a hint. Proof of the first triangular inequality can be made by distinguishing various cases. So the first case, if x larger or equal 0, y larger or equal 0, you have then that x plus y, everything is on negative, so this is equal to x plus y without the absolute value, and this is equal to the absolute value of x plus the absolute value of y, because everything is non-negative, and so equal is a particular case of less or equal, so you end up with x plus y less or equal x modulus of x plus modulus of y. And then there are other cases. So for instance, the second case, you consider again x non-negative, but y negative. So there are two cases. Cases 2a, if you have that x plus y is however positive, because you sum a positive and a negative number, the result can be positive, or however non-negative, then by definition of absolute value you have that x plus y is equal to x plus y without absolute value. And on the other hand, modulus of x plus modulus of y is equal to x minus y. Since y is negative, this is larger than x plus y, which is equal to x plus y. So you end up with reversing this inequality, the absolute value of x plus y less than the sum of the two absolute values, so x plus y less or equal modulus of x plus modulus of y, and so on and so on. So I leave you the other two possibilities. So 2b, you have x plus y less than 0. I leave it to you as a homework. And 3, the last case is both terms are negative. Homework. Okay? So try to do it. It is quite boring, but for you now it can be instructive. I want to tell you why this is called triangular. Why this is the triangular inequality. So in order to understand that, just try to use some sophisticated objects. So instead of using number, just use vectors. So instead of numbers, consider vectors. So then instead of absolute values, consider as a notion lengths. Okay? And this is the situation now. Here you have a triangle made of vectors. Sides are vectors, so this is x, this is y as a vector, and this is x minus y, coming from the ordinary elementary algebra of vectors that you know very well. So the law of triangles says that every side is smaller than the sum of the others. So here what you have is that x minus y, which is this side here, in absolute value, that represents the length of the side, is, not larger than modulus of x plus modulus of y. This is the other formulation of the triangular inequality. Of course, you could also try to do another picture. This is x, this is y, and this is x plus y. And you have the other version of the triangular inequality. So, but there is another triangular inequality, the second one. And so this is the first, so the sixth rule of the modulus, if the second triangular inequality that states the following: it translates the rule that says that every side is longer, so it's larger than the difference of the two others, namely the side x minus y here is larger or equal the difference between the length of x and the length of y in absolute value. Okay, or again, this is equivalent to x plus y larger or equal modulus of x minus modulus of y in absolute value. Now I want you to warn you about a very common but however horrible and absolutely to avoid mistake. Very often in the exam you are asked to deal with an absolute value. We like so much the absolute values for the exam. For instance, consider the absolute value of something like x squared, I don't know, minus 7x plus 10, for instance. Now you have to get rid of, first of all, when you have an absolute value, try to get rid of it and to distinguish the various cases, okay? And so, of course, this can be equal to x squared minus 7x plus 10, or the negative of this quantity, so minus x squared plus 7x minus 10. This can be one of the two. You have to say for which values of x, and that a very common but really infamous mistake is the following. You write down this and then you say this is true if x is larger or equal than 0 and if x less than 0. And this is horrible, and I want you to understand it very well, okay? This is horrible, very horrible. What is not horrible, what is correct here is just to say this is x squared minus 7x plus 10 if x squared minus 7x plus 10. So to say the argument of the absolute value is larger or equal 0 or minus x squared plus 7x minus 10 f minus x squared plus 7x minus 10 is less than 0. But now it is not finished, because we are asked to specify for which values of x. So since x squared minus 7x plus 10 is equal to x minus 5 times x minus 2, so there are these two roots. So this will be larger or equal than 0 if x is larger or equal than 5, so both factors here are positive, or x smaller or equal than 2. Then at the end, well, you finish this exercise just by saying this is x squared minus 7x plus 10 if x larger or equal 5 or x smaller or equal 2, and minus x squared plus 7x minus 10 if, on the contrary, so x is strictly included between 2 and 5. This is the end of the exercise, okay? So now let us go for the last minutes to a very simple proof about sequences. And consider this example where you have an is equal to 1 over n, where n is even, and 1 minus 1 over n if n is odd. Of course, for n different from 0. So see what happens here. Here it happens the following. You have points 0, 1. So we start from n equal to 1, and here we have a1 here. Equal to 0 because it is 1 minus 1. Then you have 1/2, which is a2. Sorry. Then a3 is 1 minus 1/3, so it is 2/3. Sorry. a4 is 1/4. The even I do it in brown. a5 is 1 minus 1/5, which is 4/5. a5, sorry. a6 is 1 over 6. So if you go further and further, you find here a8, a10, and for what concerns the odd, you here have a7, a9. So you have that the even elements wants to accumulate and the odd elements accumulate at 1. So now the question here is, what is the limit of all this stuff? This is quite an intriguing question. What is the limit? And so what is the answer? So I leave this question open, and we will see next time. This is open question for you. Okay, bye.